We are going to take one more set of notes in lesson 2.5. So at the top of this, you can put the title lesson 2.5, notes 3. So we've already taken 2 sets of notes in here. This is our 3rd set of notes. The last thing that's left to cover in this particular lesson on solving inequalities, linear inequalities. And I want you to make this statement right away to start with. Sometimes, this is a sometimes, not always, but sometimes an inequality, the only, big writing you have to do in this, but make sure you put it there. Sometimes an inequality has, and then we're going to put a colon there. There's two other things that can happen other than what we've had happen so far. So far we've been able to solve them, get an algebraic solution that says something like x is greater than or equal to 3, and then we can graph that. But then today we're going to discover that sometimes we are also going to have this situation, where sometimes an inequality has all real numbers as its solution. Sometimes it has all real numbers as its solution. In other words, the whole number line. Any number you pick off of the number line would make that inequality true. When we show the graph for it, we'd actually have to shape the whole number line. So today, here's some good news. When you do find that the solution is all real numbers, you do not have to graph it. You just have to write that the solution is all real numbers when you're done finding out that that's the case. And then the other thing that could possibly happen is that there is no solution to that inequality. No, there is not a number on the number line that would make that inequality true. So again, if we find out that there's no solution, you get off the hook for graphing it because you basically would make a number line and you wouldn't shade any part of it because there aren't any numbers on it that would make it true. So today, what's going to happen today is this is what should happen every time. You'll get one or the other of these. We have already practiced in this lesson getting a solution where it starts at a point, that point may or may not be included, and then we shade either to the left or we shade to the right to show all the other numbers that can be solutions. Okay? So you won't have any of those today because we've already practiced that in this lesson. What we're going to practice today is what happens when the solution is all real numbers or the solution is no solution instead, because now we actually have 3 things that could happen. So in your practice today, that's what should happen, is one of these 2 things. Okay, so let's put practice. And let's practice the first one that happens. I should have done this in my notes that I have copied here, but let's, number 1 where it says that we are going to get all real numbers as a solution, let's practice 3 of those. What happens when we get all real numbers? What does that look like? So here's our inequality. X minus 2 is less than x plus 1. Here we have, do we have any simplifying to do?
No.
No? Okay, then the next question we ask ourselves is we have variables on both sides.
Yes.
Okay, so when we have variables on both sides, what do?
Get rid of them.
Get rid of them on one side or the other. You get to pick which side you want to get rid of them on, right? Okay, well, in this case, it's a 1x on the left side, it's a 1x on the right side. So which one do you feel like you want to get rid of? You want to get rid of them? Doesn't really matter, does it? So let's get rid of them over here on the right side because then we'll have our variable left on the left side maybe. So we're going to subtract x from both sides. Now remember, if this is subtract 2, we can change that to add the
Opposite.
opposite, so that's really a negative 2, isn't it? So x take away x, what happens?
There's no X left.
There's no x's left on that side, so we have negative 2 to bring down. X take away x on the right side, what happens?
So there's no X there.
The x's are down again, there are no x's on the right side. So we bring the 1 down. We have no x's in our statement here, do we? When our variable, whether it's x or whatever variable it is, disappears totally like it did here, and we just end up with a mathematical statement, now we have to evaluate, is that true or is that false?
It's true.
So negative 2 is less than 1. Is that a true or false statement?
True.
That is true. So let's put true. Okay. So because, and I want us just this one time in your notes, I want you to write that down. Why are we going to say that what the solution is? In other words, what happened now? Because x eliminated means gone, right? Because x eliminated and we have a true statement, so because x eliminated, could have been any other variable, could have been n or a or whatever, but it's the variable x eliminated, it's gone, and we ended up with something that is true. The solution is all real numbers. The whole number line, it would not matter what you picked. It would not matter what number you picked from that number line and put it into the inequality statement, it would make it true. So because our variable eliminated, in the process of solving it, it just like disappeared on us. We ended up with something that is true. Negative 2 is less than 1. We can say our solution is all real numbers. What did I say about graphing this?
You don't have to.
Don't have to graph it. Because what would be true if we did graph it? What part of the number line would we shade?
Both sides.
Yeah, both sides, everything. And do we even have a starting point? Would we even know where we would want to start? No, we don't even really have a starting point. We'd just probably draw a number line, make it, take a picture of it, say, okay, well, here's 0, and here's 1, and here's 2, and we would just have to shade the whole word. So we're not going to go. I'm not going to have you shade. I'm not going to have you graph these. Like you get to just write. You don't get to stop though at the true. You have to stop and say to yourself, oh, the variable eliminated. I ended up with something that's true. That tells me that I have to write down what the solution is, and the solution is all real numbers. Okay? Let's try another one.
So,
Yes, Isaac.
do you just have to write all those numbers, or do you have to put in a sentence?
No, you're not going to have to write out this sentence answer all the time. We just wanted that in our notes. Okay? So now we'll practice one that would, this is the kind of thing you would actually show in your work, okay? When you're doing these for homework for tomorrow. So here's our inequality. Again, first question is always, do I have to simplify?
Yes.
Okay, which side needs to be simplified, or do both sides need to be
Left.
simplified? The left side needs to be simplified, doesn't it? So we need to do our distributive property. So what does the left side become?
2x plus 6.
2x plus 6 is greater than 5 plus 2x. That side can't be simplified, right? Okay, next question you ask yourself is, are there variables on both sides?
Yes.
Okay, so which side should we get rid of them on?
Is that right?
Okay, we're going to get rid of them on the right side. What would we do to get rid of them?
Subtract 2x from both sides.
Subtract 2x from both sides. Okay, so we'll subtract 2x on each side. And what's our resulting statement now?
6 is better than 5.
In other words, the 2x, take away 2x on the left, the x's are gone. And we have just 6 left to bring down. And the 5 comes down, and 2x, take away 2x again is, they're gone. So our variable eliminated And is this a true statement or a false statement?
True.
Is 6 greater than 5?
Yes.
It is true. So I do want you to write true. I do want you to write that. But now you have to say to yourself, okay, the variable eliminated. I ended with a true statement. I have to still say what the solution is. So what would I write next, Trey?
All real numbers.
All real
But is-
numbers.
but like at my old school, I already did this. Isn't there a symbol for all real
There
numbers?
sure is. You guys want the shortcut?
Can we write the symbol?
Yeah, do you know what it is?
I can't remember what it is.
Well, then maybe I shouldn't let you write it. No, I should give it away, huh? Okay, so the all real numbers is our actual solution. And I want you to write that right now, though, please. Write that. And then I will show you what the mathematical symbol is for all real numbers, because math has a lot of words that can be replaced by mathematical symbols. It looks like this. You make a double side for a capital R. That look familiar, Trey?
Yeah.
Yeah. Okay. So that's the symbol for all real numbers when you want to take that shortcut. Okay. What's really important here that students forget to do is they forget to write what the solution is. When the variable eliminates and they end up with that statement, they will often remember to write the true or the false or what, and then they stop right there and don't still say what the solution is. You and I need to know what's the solution to this inequality. That true or that false, that variable eliminating and that true or that false just tells you what type of solution it's going to be. Okay, I'm going to give you one to try on your own here, and let's see what happens with it, okay? So, C, a third problem under 1. So 4 times, in parentheses, x minus 1 is less than or equal to 4x minus 4. Go ahead and solve that and see what happens. When you're finished with it, go ahead and look up and see if you agree with me or you need to challenge it. So again, the variable should have eliminated. Right?
I have a question. If we can see that if we solve it all the way down, that we know it's going to be all real numbers, can we just stop where we see?
Okay, at what point did you know it was going to be all real numbers, Trey?
When it was 4x minus 4 is no 4x minus 4.
Okay, how did you know at that point it was going to be?
Because it was the same on both sides.
Because it was the same on both sides. Okay, we have to be really careful though. Be really, really careful about that. That's called in an equation, when there's an equal sign in there, that's called an identity. And when we have an identity, one side is same as the other side with an equal sign between them, we can say, we can stop right there and say it's an all real numbers solution. This is an inequality though, so we have to be really careful. What has to be in the inequality symbol for you to be able to say, oh, that left side matches the right side, so I can say the solution is all real numbers. The equal to bar has to be part of the inequality symbol. Is the equal to bar part of this inequality symbol?
Yes.
Yes. So in other words, it's the equal to bar in this that makes this true, isn't it? -4 is equal to -4. So we have to be really careful about that, Trey, because when we start discovering what happens with no solution, we have to make sure that we keep that straight, okay? Isaac.
Would we ever come across something that's like not true, like 5 is greater than 7?
Yeah, that's what's gonna happen in our next one, we're gonna practice. Okay. So are we done here?
Yes.
No, we're not.
Oh, we have to write all around numbers.
Yeah, we still have to write what the
Yeah,
solution is.
Or the.
Yeah, and if you wanna do this, you can write the symbol, the solution is all real numbers, yeah.
That's nice.
You can either write the words, because that makes more sense to you, and you wanna make sure that you understand what your solution was, or you can use the mathematical symbol for all real numbers that is a lot shorter. But you do need to write what the solution is. So when you said, yeah, we were done, no, we weren't. Any other questions at this point? Okay, then next I want you to write that we're going to do problem number 2, and we're going to have 3 problem number 2s. 2A. And remember, what was number 2 of about what did it say our solution would be in those? No solution. So now we're going to discover what happens when there is no solution to a problem. So let's write down the inequality. 3 times in parentheses x minus 2 is less than 3x minus 8. First question, is there any simplifying to do?
Yes.
Yes.
Okay? So we got to go ahead and get our simplifying done. So we can change this to add the opposite. We can change this one to add the opposite. What does the left side become?
3x plus negative 6.
3x plus negative 6 is less than 3x plus negative 8. Okay, we've done our simplifying. Next question you ask yourself?
Are there variables on both sides?
Are there variables on both sides? Are there?
Yes.
Okay, so what are we going to do?
Subtract 3x on both sides.
Subtract 3x from both sides. We have 3x on the left side. We can say if those are the ones maybe we're moving. But if we do it on one side, we got to do it on the other. What happens? The x's eliminate on both sides, don't they? And we end up with negative 6 is
Greater than negative
is less than
8.
negative 8. This is where it's really important we understand what those inequality symbols say. Because now we have the statement negative 6 is less than negative 8. True or false?
False.
That's false, isn't it? So we say false. So this is one of those situations where the variable's eliminated. So let's put that down this one time in your notes. I want you to write this down. Because the variable eliminated and the remaining statement is false, so this is exactly what happened. Because the variable eliminated, our variable went away. The resulting statement that we had, negative 6 is less than negative 8, that was false. So because the variable eliminated, this is not a D, this is an EL right here. Kind of looks like a D, doesn't it? Because the variable eliminated and the remaining statement is false, there is no solution. There is not a number on the number line that when you put it in, it will make that true. So again, do you have to graph when there's no solution?
No.
Because why?
That won't make sense. You don't have like a starting point and you go like
We don't have a starting point. Would we have to shade anything?
no.
No, we wouldn't even have to shade anything because there's no solution. So we can stop and say right there, no solution, and not have to graph it. Questions about that one? Okay. Second problem. first question? You're talking to yourself. What's your first question to yourself? Do I have to simplify? Do you?
Yes.
Which side?
Both.
Both sides this time. So it might be a good idea to change that subtraction to add the opposite in each of them first. And then you're going to do distributive property on both sides. So on the left side, we're going to end up with negative 4x plus what?
8.
8, positive 8, is greater than or equal to 12
plus
plus
negative 4x.
negative 4x.
Add 4 to both sides.
Add 4 to both sides? Really?
Because it's negative. Wouldn't you
Add
the opposite?
4? How about 4x? How about we add 4x to both sides? There's a difference between 4 and 4x, is there not? Okay, so we add 4x because a negative is being added. So we add its opposite, which is positive 4x, and now we have what's our resulting statement?
X is greater than or equal to 12.
X is greater than or equal to 12? Don't these x's over here
Cancel. So
go
it's
away?
Yes.
So we have 8 instead of x, right? 8 is greater than or equal to, and what happens with the x's on this side?
Cross out.
They eliminate also, so we have x is greater than or equal to 12.
You said X.
Did I do it too? 8 is greater than or equal to 12. See what you do to me, Nancy? True or false?
False.
False. So we say, okay, that's a false statement. Are we done?
No.
What do we have to do?
No solution.
We have to write no solution. This tells us, all this is doing is telling us one of two things. When the variable eliminates, then you have to ask yourself the question, is my statement true that's left, or is my statement false? If it's true, the answer is what?
All real.
All real numbers. If it's false, the answer is
No solution.
no solution. So here's our final answer. Okay. Any questions about that one? Great.
Isn't there a symbol for no solution as well?
I bet there is. Do you know it?
It's a circle with a slash.
It is a circle with a slash through it. The symbol for no solution goes like that. The mathematical symbol for no solution is a 0 with a slash through it. Okay. Let's do one more of those and then I'll let you be done here. Okay? I want you to try this one on your own, see what happens. You end up with the same statement I do. 5 is less than or equal to 3.
Yes.
Is that true or is that false?
False.
That's false. 5 is not less than 3, nor is it equal to 3. So that's false. So we're done?
No. You gotta do the no solution.
We gotta do the no solution. And what's our symbol for no solution again?
0 is a slash.
0 with a slash through it. Okay, there's our solution. No solution. Anything that needs to be cleared up with these. Again, what should happen in your homework today is just practicing these types of problems. Then we are going to have to combine though, the fact that all three things can happen. We can get a solution and we are going to have to graph it on a number line, or we could get our solution could be all real numbers and then we don't have to graph it on a number line, or our solution can be no solution and not have to graph